Can we get the lights? I actually wanted to buy a new phone at Christmas, and I went into the shop and I said, okay, the only thing I care about is that I can flip it open. And do you know how many phones they had that you could flip open?
No.
0. Only smartphones. No good for me. No good. Okay. Now this lesson we're going to have a look at, well, it's called Venn diagrams, but maybe I should really have called it sets. Yeah? Can we see? Yes. Now, this lesson on page 92, I'm hoping is more of a revision, really, of what you did in middle school with sets. Okay? So what I mean by a set is a well-defined collection of elements. Now that sounds very fancy. What does that really mean? It just means that a set is a list of things, really. So for example, here's a set. The set of I don't know, rainbow colors. So that would be something like red, orange, yellow, green, blue, indigo, violet. So with a set, you have these called braces to represent the set. And in fact, it doesn't really matter about the order. So if I wrote it like this: violet, indigo, blue, green, yellow, orange, red, that's the same set. Okay, so I mean, this is familiar to people, right, from middle school, or not? I don't know. Okay, continue. So how do we show that an element belongs to a set? Well, we use this symbol here. So if I write something like A element A, this means A is in set A. And then if I use my rainbow colors, for example, black is not an element of the set of rainbow colors. There is no black on a rainbow. But something like red would be an element of the set of rainbow colors. You've seen this symbol before, yeah? Yes? Continue? Yes, continue, yeah. So we can also draw these sets. So for example, if I go back to my rainbow set, we usually draw sets as a circle. So this would be the set of rainbow colors. So in this set would be red, orange, yellow, green, blue, indigo, violet. But there are some colors not in this set, and we would draw them outside the circle, like for example black. What else? White, yes, we don't get white in the rainbow, and so on. So we usually put this in a big rectangle, and this is called it's like the universe. It's the universal set. It's everything. So all the colors are in this rectangle, and only the rainbow colors are in this here. So let me just get rid of that set of rainbow colors. I don't know, what are the colors?
Pink.
Pink, yeah, okay. Pink, gold, um, um, silver, um, purpley, and so on. Yes, we get the idea. Okay, continue. Yes. Okay. So let's have a look at if you have two sets. So for example, prime numbers 2, 3, 5, 7, 11. These numbers look familiar? These are called prime numbers. Odd numbers 1, 3, 5, 7, 9, 11. And then maybe here, this is the universe. Maybe that could be all numbers. Or something like this. It's not important right now. So we can draw this as two sets. This set is the prime numbers, and this set is the odd numbers. And this overlap here, this is the numbers which are both in both sets. So I can see only one number. What number is that? Or can I even see? No, actually I see many numbers here. 3, 5, 7, 11. Here are the numbers which are odd, but not prime. And here are the numbers which are prime and not odd. So what goes in here? There is one number, 2. Yeah. Oh, and 9 is odd but not prime. So there's a 9 here as well. So you can draw them like this. But these have names. This part here where it's the common between the two sets. Does anyone know its name? Very good. Intersection. Intersection. And it has a symbol as well. P intersection O. This is the two sets, what they have in common. And this set here, where it's everything that is prime or odd. So that would be 1, 2, 3, 5, 7, 9, 11. Everything that's prime and odd. That has a name as well, which is called, does anyone know? Anybody know? Union. Yeah, and the symbol is a U. It's the opposite, yeah. P union O. So this is called intersection and union. Continue? Yeah? Okay, let's go down a bit. Okay. So let's say we have the universal set. So we're looking at all the numbers from 1 all the way up to infinity. Okay. And let's say set E is the set of even numbers 2, 4, 6, 8, 10, etc. This symbol here, oh okay, well let's do some true false. Let me just write some stuff down here. Question? I'm checking, these are true false now. Okay, so the first one, true or false. 2 is an element of E.
True.
This is true. 3 is an element of E. This is false. 4 is not an element. False. E union the universal set is equal to E. This is false. Yeah, if you put these together, if you put E and U together, it doesn't only equal E. E union universe equals universe. It is true. This is true. This is true. And the set contained in 2 is an element of E. False. So be careful, there's a difference between this and this. So this is not the same thing as this. This is one element, so this is an element, but this here is a set. By the way, if your set is empty, this has a name. What's it called? Not the empty, well, yes, I suppose you could call it the empty set, but it has another name as well. It's called the null set. And there's another symbol for it, which is that. Null set, empty set. NULL, yeah. Huh? This here?
Yeah.
Oh, we're back here, is it?
No, the last one.
Here, yeah?
Yeah, the last. Is that two?
This? Wait, hang on. Am I looking here or am I looking here? Top or bottom?
Top.
Top. Okay, here, yes. What's your question?
Why is that two not including?
Oh, why is this false?
Yeah.
Yeah. Can I go down? Explain? Okay, so let's say I have A equals 1, 2, 3. We can say 1 belongs to A and 2 belongs to A and 3 belongs to A, and that's fine, yeah? Let's say that A only equals just 1, so I get rid of these. Okay. Can I say 1 belongs to A? I can. But I can't really say the set 1 belongs to A. I mean, I could say the set 1 equals A, but this is not the same thing as just 1. They're different. They're different things. So I could have this, the set with the set 1, the set 1, 2, the set 1, 2, 3. That's not the same thing as the set 1, 2, and 3. Because if I'm in this, I must be 1, 2, or 3. But if I'm in this, what must I be? I could be the set 1, the set 1, 2, or I could be the set 1, 2, 3. So there is a very important difference between this and this. They're not the same. They're different things. You know, for example, if I borrow this and here, so if I write here, so this is a set is like a list. Okay, so here's my set. What is in my set? Just calculator. That is very different to this. These two things are very different, aren't they? So this is a list that contains calculator. This is a calculator. So there's a difference between the two. Yes? Okay. Continuing. What did I want to say? Oh yeah, so I didn't get a chance to say this yet. Does anyone remember what this symbol means? Yeah, this is not A. So these are the things which are not in A. So I don't know. I'll give you an example. Yes, okay, I'll give you an example. So let's say we have the universe, our universe, my universe is everybody in this class. So the list here would be well, you all know your names, this class. And then set P are the people who are here now, right now in this class. So P dash are all the people who are not in P. So what would be in this set? Yeah, and who's that? Malik. So when he watches this video later, you can see that he was here. Okay, so Malik is the only person who's not here. So they are, we would say that Malik is not in the present set. So therefore Malik is in the set which is everything except P, outside P, not P, which is this one here. Oh, sorry. Like this. Okay. Okay, so there's the other thing to do. Can I scroll down? Right, so sometimes smaller sets are in bigger sets. So we could have a set here, and in this set could be the numbers 1, 2, 3, 4, 5, 6. This could be set A. A equals the numbers 1, 2, 3, 4, 5, 6. And then maybe set B could equal 2, 4, 6. And you can see that B, there it is there, 2, 4, and 6. That is inside this bigger set. Everything that's in B is also in A. Is there anything that's in B that's not in A? No. Everything that's in B is also in A. So we can say that B is a subset of A. Subset. So B is a subset of A. Question? Now there is a bit of a difference between that symbol and that symbol. So yeah, both mean subsets, but this symbol here has an extra meaning. Does anybody know? Close, go on, try. Use your best English to explain it. No, give up. Yeah. So the difference here is, in this one, you're saying that B could be a subset, or it's possible that B actually is the same as A. Whereas in this one here, you're saying that B must be smaller than A, and you're making it clear that B can't be the same as A. So for example, I could say 1, 2, 3 is a subset or equal to 1, 2, 3. I could say 1, 2 is a subset of 1, 2, 3. I could even say 1, 2 is a subset or equal to 1, 2, 3, but I know it's not equal. But what I can't say, this is wrong, I can't say 1, 2, 3 is a subset of 1, 2, 3. So it's okay to say this, this, and this, but it's not okay to say this. Yeah, so just be careful with this one. If you're using this, it means you're very clearly saying that B is not possibly, could not possibly be equal to A, that it must be smaller. Oh yes, and one last symbol. I suppose nowadays people would want to call this hashtag, but not hashtag. This is size, and it literally means how many. So for example, this here, how many? 1. How many elements are in this set? 3. Yeah, I see, I tricked you now. How many elements in this set? 0. Yeah. How many elements in this set? 2. Because this set here, you have A is an element of A, B, and B is an element of A, B. Have I missed any elements? Oh, I've already done A. A is an element of A, B is an element of A, so there are 2 elements in the set. So in other words, you don't care that it's twice. I mean, that is the same thing as A, B, and it's the same thing as A, B. Because both of these sets, they make the same statements. A is a member and B is a member. It is true for all of these, so it means they're all the same. You know, it's like if I said, yeah, let's call this statement 1, and we'll call this statement 2, and we'll call this statement 3. So, and we'll call this statement 4. All of these are the same. You know, if I said the set is AAB, that's the same as saying A belongs to AAB and B belongs to AAB, but that's the same as A belongs to AB and B belongs to AB, and A belongs to AAB and B belongs to AAB. They're all the same. So in fact, we don't care if we repeat, as long as we make the same statements here about who is in and who is out. So they all make the same statements about who is in and who is out. So we don't care that they're repeated. Okay. So like I said, I really hope that this is more revision of what you did in middle school. What I'd like you to do, I would like you to do all of them because they're all really, really short. Like for example, it'll take me 10 seconds to do the question 1. So we'll do question 1 together as an example. They're all true, false. So let's have a look at it together. So number 1, part A. True or false? True. Next? True. Next? True. Next? True. Next? False. Next? False. Next? False. Next? Yes. False. Next? True. Next? Good. And next? What are we saying? True, false, which is it? It is false. What do you mean, why? Is the set 1, 2 in the set 1, 3, 2? No. No. Yeah. Oh, sorry. So it's true. It's true because it is not in it. Yeah, sorry. It's true. Okay, and then the last one, true or false? It is false because the set 1 is in the set of the set 1. Yeah, okay. Very good. Now let's look at the next one together. True or false? True. Next one. True or false? True. Next. True, yeah. Next. True, yeah. Next.
False.
Very good. False. Next. True. Next. What are we saying for G? True.
Yeah.
H.
True.
Yes. And I.
False.
False. Very good. Okay. Right. So again, this I would like you to do all of. Again, for the same reason that you don't have this chapter is new to the exam, so we don't have any exam questions to practice. So I would like you to do all of these, but they're very quick to do. You know, we just did question 1 and 2 together, okay? So can you just try these for 5 minutes and then we'll finish, okay? Just give me 5 minutes. Huh? Oh no, we just did 1 and 2 together, so just finish them now, yeah.